share this screen. See yourself.
Nope. Other than know what's on the screen. That's not important. Let's take the PowerPoint out. Close everything.
No, don't close it.
I know. You don't need that. That's not the one I need. I know that's not what I need. I need that one. All we good? You seen everything? Slides moving? Okay. Yep, just want to make sure I was pumping it out. Okay. Yep, but I don't want to be seen. There's times I mean, look, the PowerPoint's the show. And most of the PowerPoint has the words on it. Zooming on just this ugly face down in the corner. I'm bogey. I was listening. Let's see how small I can make this screen. So this is the Vixen Call Advanced screen that we're talking about. It looks like what's getting pumped out. Control booth problems. So are we live now?
Yeah, you're live.
It's live and crashing and not crashing and creating chaos among everyone. Hey, everybody. Welcome to Wednesday live broadcast. Here we're talking about First Light Chronicles, and I've been thinking about star parties a lot, starting to do a lot of more star parties. I have a big one coming up this weekend. It's going to be a music festival here in Northwest Arkansas. And the astronomy is half of the star party. We're going to be doing. We're the stars part of Stars and Sauce. Tyler and I will be over there, along with a lot of volunteers from Sugar Creek Astronomical Society and others. And we're going to be showing, hopefully, 3,000 to 5,000 people views through our telescopes. We did this once before back in September, and had, I think, 1,500 people come through. It was fantastic. And people are wanting to get out more and more, and more people are vaccinated. So we're still going to be safe and practice what we can of good, safety. But we're going to be showing lots of people stars, and these people are A-OK mellow, and it's going to be a fun time to be had by all. But that got me started thinking about, okay, star party etiquette, and expectations. A lot of these people have never looked through a telescope before, and our job is to manage expectations. So I have a PowerPoint. So here we go. Going to get that PowerPoint squared up. And Paul, tell me when I can go. Yep. So he's going to be pumping out the PowerPoint. There we go. All right. So we're going to talk about your expectations. If you've never looked through a telescope before, what you think you'll see versus what you'll see. So we're oftentimes managing these concepts, and this is what people think they're going to see, because these are the pictures that people see in magazines and on their social media feeds, and man, they want to see that. And that's obviously Jupiter on the left and Saturn on the right. Both spectacular photos, but not what you're going to see. This is what you're going to see when you're using an Explorer Scientific 127 millimeter telescope with our 82-degree eyepiece, 8.8 eyepiece, 8.8 millimeter eyepiece. This is a high-powered eyepiece, and that's what you're going to see on Jupiter, and that's what you're going to see on Saturn. Really weird expectations, and people want to see those really big pictures. You're not going to see that. If you get up at really high elevation and have a really big telescope, you're going to be able to put some more magnification to it. Likewise, every once in a while, you can pour some really high power magnification to it and see Jupiter and Saturn at higher expectations. But the reality is they're going to be small. What you want is really sharp, and you got to sit there and look at them. So trying to manage some expectations. We're going to talk about what the difference is here in a minute. And okay, so we look at the moon. This is the expectation of what you think you'll see, and here is what you will see. And you're right, there was no difference in those images because you're going to see that through a telescope. The moon's close enough that we can do some serious viewing on it. And in addition to that picture of the moon, you're also going to be able to see a lot of this stuff right here. You're going to be able to see even this, which are close-ups of the moon. You can see craters, relay, mountains, valleys, all sorts of stuff. The moon is something that you can pour really high power to and see things. So when you go to look at the telescope for the first time, a lot of these things are, counterintuitive. You're going to be able to think you can see these big planets, and you can't. So, what's going on here? Why do you think you're going to see Jupiter on the left, but see Jupiter as it really is on the right? That's because your eye is not a camera. The picture we're looking at here is taken by composing or stacking hundreds of images of Jupiter on top of each other. So what they're going to do is they're going to take a video, because Jupiter's bright, and you take like 30 frames a second, and tell the computer to look for the ones that are in the best focus and throw all the others out, and then take those that are in good focus and stack them up. And through the miracle of stacking, there's this process called signal to noise ratio. The signal is always in the same spot, and the noise is random. So you take these really nondescript images of Saturn that don't look like much, and you start stacking them up, or Jupiter or Nebula or whatever. You start stacking them up. The signal, in other words, the image of the planet, is always in the same spot, and you stack them up, and so the details begin to emerge. And then there's other manipulations in Photoshop or other photo manipulation programs you can have. And so you can create these images that are really large and look really sharp and crisp, but your eye can't see them because your eye can't stack or build up data. Okay, so the next slide, here we go. Your eye is a wonderful device. You can see wonderful details, but it comes with time and experience. So while that may look like a small picture of Jupiter, the reality is if you sit there and look at it, and the more you look at it, the more you begin to see, the more details start coming out in your eye, and you can start seeing those things. Actually, I think that may be Saturn right there. And so your eye can see many, many things live. You just can't see those large, big, honking images. So why is the moon so different than a planet? Because we can really blow the moon up, and the expectation is to see what we can see with the moon. The reason is distance. Distance is the reason. Jupiter is massively larger than the moon, but from our perspective, it's really far away. The moon averages 238,000 miles away from the Earth. Okay, that's all well and good. Jupiter is 379 million miles, will round up, call it 380 million miles away. Okay, massively farther away, and it just can't get big. Now, how far away is it? It's more than 4 times the distance from the sun to the earth. That's called an astronomical unit. It's more than 4 AU away from the earth. It's 33, averages 33 light minutes from the earth at that distance. Obviously, it gets farther away and closer as it goes around its orbit and earth goes around its orbit. But think about that. If somebody, the spaceship's probes at Jupiter, it takes 33 minutes for our command for it to do something to get there, and then it goes okay, and it takes 33 minutes for that answer to get back. All right, so Jupiter, it's the largest planet, but it is so far away. It looks small, and it's going to be small in a telescope. So managing a little bit of expectations of what you can see. The moon's going to look like what you want it to look like, and you've seen in pictures. However, the planets are not going to be that way, and that's the same for nebula and star clusters and things like that. They're not going to look the same as all these great pictures that you see, like this fantastic picture of Jupiter with a great red spot, all sorts of detail in the cloud filaments. It's just not what you're going to see. So moving on. Paul, do we have any comments? I can't see the comments over here. Yeah. So what you got?
Let's see here. I'm still working.
Okay, so we're going. All right, Star Party. Okay, you got it? Okay.
I'm just trying to get the mics up and working. So yeah, we do have comments, and what they are is Mr. Mike Wiesner says, "Happy International Dark Sky Day."
Hello, Mike Wiesner.
And Paul Burgart says, "Howdy to everyone on Dark Sky."
Hello, Paul. Thanks for joining us.
And then Mike Overracker says, "Hello, all."
Overacker.
And Billy Zastro. And you there, Scott. I am sitting here at the Texas Star Party with Greg Bragg. He said hello.
Hey, Greg. Nice to hear from you as well. Greg is a former Explore Scientific person. Yes, Scott is not with us. He's been traveling. He went to the East Coast, and now he's traveling back from some time in Georgia. Took some time off to go see some people, and he will be back here tomorrow, back in the saddle again. So,
Ken
moving on.
Is here,
sir?
And
Sir?
Ken
N, and who else?
Harold Locke.
Hey, Harold. How Ken N?
And C Fox 0011 says, "Some say stars twinkle, but planets don't. Is that true?"
Yes. Okay. We'll attack that question really easy. That's an interesting Question: stars do twinkle, and then stars don't twinkle. Star twinkling is caused by different densities of air moving between your eye and the star. So think about water. When you're looking at a perfectly calm pool of water, you can see, like a swimming pool, you can see the bottom of the swimming pool very, very well. You can see little rocks, you can see leaves, you can see the shape of the leaves, you can see the detail and color of the leaves, right? But if you start slapping your hand on the water, the surface of the water starts changing and the different density of the water changes because those waves are higher and lower, and that causes the light to refract in different directions. The air is exactly the same thing. Really cold or really, really steady air with no temperature variation in it, the stars stop twinkling. You'll see this effect on really cold nights, and I've seen it also when there's a very high wispy, very thin, not wispy, but very thin, very smooth cloud cover come over. There was one star party we were doing at Pea Ridge National Military Park in particular. I saw some clouds coming over, and we were looking at Jupiter, and clouds were starting, a cloud, just a very thin layer you could see coming in. And I was hopeful this was going to happen. Everybody else started packing up. I waited, and that cloud meant that the air was all steady, the same temperature, and very steady. And the scene became very, very good on the planet. And the stars, likewise, didn't twinkle very much. So that means that there's not a lot of refraction. So the light of the star is a pinpoint, but it's continuously moving like that. And that's what makes a star look like it's twinkling, because the air is actually causing it to refract. Now then, if you've got a planet that's up there, that difference in air temperature is causing the pinpoint of the star to do this. But the planet is a disk, so it didn't have a pinpoint. So you can't see that light changing, right? So this is a weird thing when you take a telescope and look at a low power on Jupiter or Saturn and you see the stars twinkling. Jupiter and Saturn, when they're very low magnification, look extremely sharp and crisp. But when you start magnifying the planet and trying to zoom in, you think, man, that is astoundingly sharp and crisp. I can really, really increase the magnification. You're going to find that what you're doing is you're increasing the magnification of that refraction. That air differential, as it moves across the face of the star, or the pinpoint of the star, is constantly making the star do this. Well, that same air is moving in front of the planet, right? But it's not doing it on a pinpoint scale, but it's causing the surface of the planet to go like this, right? And so all over the planet, it's doing this at a different rate, right? The different density will move across and they'll make it go here. And as it goes, it makes that surface twinkle, but you can't really see it with your eye because it's not a pinpoint. So what happens is under low power, you can't even see it, but you go to high power and suddenly the planet looks mushy, brown, jumbled up, and the scene is not good. There's not steady skies. So the stars twinkle because of the air, different densities in the air, and the planets don't twinkle, but they're still affected by that same air, and the quality of the scene can be very poor sometimes when you put power to it. At low power, it can be okay, but at high power, that's where that's going to come in. That was a great question. Thank you for asking. Paul, what else we got? Anybody else?
Wow, we've got tons of questions. Unfortunately, my computer is not allowing me to display them at this moment. Let's see here.
So I'll go ahead and we'll start with the star party. When you get it back up, give me a holler and we'll stop and answer some questions.
Okay.
All right. So when you go to a star party for this first time, like like when you go to a social party, if nobody told you to don't double dip your chips in the dip, you will create a party foul. Well, same thing can happen to you. Star party etiquette, night vision. The pictures here obviously give you an idea of what a pupil does. The human eye is a miraculous creation. Under bright light, the pupils get small, but under dim light or absence of light, your pupils get very, very large, just like an owl's do. Owls does. Letting that pupil relax and get bigger and bigger can take, for full effect, 30 or 45 minutes. But even after 5, it starts helping you see in the dark. And so what happens is that pupil gets bigger and bigger and bigger. But the first time you see white light, like you go, oh, I wonder what time it is, and you open your phone and hit your phone and look at your phone. Now your phone is a bright white light almost always. And that white light instantly makes your pupil small again. And now you've got to wait for that dark adaptation to happen. So I have an iPhone. You can take your iPhone, go into the accessibilities setting, go down to color filters, and turn on the filters and make it red. And then you can use your smartphone. I'm sure an Android has the same thing. And I turn the brightness way down because a bright red light will do the same thing. You want a dim red light. And so the red picture over here looks like maybe a supernova remnant or something, but in reality, it's a picture of a red light on the ground, shining red light. And, the picture shows that bright white spot in there that's really not there. So understanding, don't pull your phone out at a star party unless you're going to set those red settings and turn the brightness down. Likewise, relax and let your eyes do the job. Many, many people that come to the star parties that we put on have never really been outside and experienced darkness before, and they're very scared of it. They're not comfortable because they're way out of their element, and you'll see using their flashlights to walk around. Well, just stop, let your eyes adjust, look down at the ground, and move slowly. Don't lift your feet up, just sort of shuffle along. And, you be aware if you're in a parking lot, there could be curbs and things. You got to find those things. But there's ways to do it and still be safe and protect your night vision. The more you protect your night vision, the more you're going to see. So the other thing is no touching. Don't touch the telescope. So this is a picture taken out in front of the Explore store with one of the shipping folks, Ryan Main. He is touching the telescope. When you touch that telescope, the eyepiece, and a lot of people want to come up and grab onto it like a pair of binocular, right? Well, that makes the telescope move, and the telescope moves, and you can't see anything because telescopes vibrate, and the more you hold, or you're even going to move it. This situation where just don't touch the telescope. So what we're talking about, if you're just joining us, is star party etiquette. When you go to a star party, there's some things you need to know ahead of time. A star party, for those of you who may not know, is a gathering of astronomers where we use our telescopes all together in a group. A lot of astronomy clubs, like my astronomy club, Sugar Creek Astronomical Society, has public outreach where we get, anywhere from dozens to hundreds. And one time we had an estimated 1,800, 2,000 people show up at one. That was a crazy night. And there's things you need to know. So here's another little tidbit. No running. If you want to get yelled at or see a grown man cry, run, trip over a telescope and knock it over. Don't run at star parties. 1, it's dark. 2, it's dark. And 3,
it's dark.
It's dark. So, if you're going to have kids out there, you want to tell them don't run. Here's another thing that I don't have a picture of. Lots of kids have these shoes that light up when they walk. Those are great up until the time you're trying to preserve your night vision and they have white and green and yellow lights, in which case suddenly your night vision goes away. Now, at a public star party where we go, the night is not a dark, dark sky. But if you're going to come to somewhere like Oracle State Park in September for the Arizona Dark Sky Star Party, which Explore Scientific is putting on, there we will be enforcing white light restrictions. And if you have shoes that light up, we're going to ask you to either figure out a way to turn those shoes off or switch your foot gear to something else. So we're going to be up with hosted by Mike Wiesner. He lives in Oracle, Arizona, where the Arizona Dark Sky Star Party is going to be held September 1 through 25 or something like that. It's on our website. And you too can come. It's going to be a great time. We're working on programming right now, but you need to get your tickets to get out there. It's going to be supremely dark, and we're going to have a fantastic time out there with Mike Wiesner. All right, some more Star Party etiquette. No smoking or vaping. Glass on the telescopes does attract and love smoke to stick to it. So, there's always some smokers, and we ask them to ensure you are very good downwind from where we are. If you just have to light up, same with vaping. That moisture that comes out and the chemicals in there will stick to the surface of the glass and cause us problems. So no smoking or vaping. And if it's a calm night, then you really can't smoke. If there's a little wind that's guaranteed to make it blow off the observing field, yeah, you can do that. So, I don't want this to be all negative, things you can't do. There's lots of things you can do. What can you do? Well, you can raise your hand up and ask a lot of questions, right? Now, raising your hand up at night where there's no light won't do any good, so you just got to ask questions. People that go to public star parties are almost always, it's a rare person that goes and takes a telescope and doesn't like to talk to people. We love to have questions about our telescopes, about what we're looking at, all those things. Paul, have you got any questions? Have you got it figured out?
Yeah.
I'll take that as a
It's
no.
going down pretty hard over here. So we're looking at hello from Eastern Europe, Matas Volkovas.
Ah, welcome to the show. Glad to have you, and thank you for letting us know you're in Eastern Europe. Welcome.
Harold Locke, Beatrice Hines, James Dugan,
He's from down under. He's an Aussie.
Ani Eunice, Jim Zastro, Mr. Mike Wiesner again. Yeah, they're just kind of having a good time in the
Yep,
comments.
they have their own side conversations going, but you're not seeing questions, right?
Not that I can tell.
Okay, he's not. So I don't think it's functioning well over there. So here we go. Moving on. What else can you do? You can be curious. By golly, be curious, because curiosity may have killed the cat, but guess what? You're not a cat. You may be a cool cat, but you're not a cat. And so be curious. Curiosity is a wonderful thing. Be curious about what we're doing, about what we're seeing, and to satiate that curiosity, back to slide just before, ask us questions. I love it when a kid comes up who just asks a ton of questions, because they're generally not afraid to ask questions. And sometimes adults are shy about asking questions, and the adults are sitting there listening attentively, but the kid's the one asking the questions. So always be curious. And what else can you do? You can marvel at the wonders of the universe. Here we have a Milky Way shot. Marvel at the wonders of the universe, because there's a whole universe up there above our heads. And if you live where 80% of the people in the United States live, and around the world, really, they can't see the Milky Way. Here's a picture of the Milky Way. Now then, just like looking at this picture of the Milky Way, that's not what the Milky Way looks like. Those reds you see down in the bottom and those brighter areas don't look like that. Why? Because just like those pictures of Jupiter and Saturn, that was taken with a camera and it stacked up images over time. Your eye doesn't do that, but the Milky Way looks spectacular with what Ed Gunther calls the Mark 1, and I've added R, and the Mark 1L, original astronomy devices, your eyeballs. Get out there with your eyeballs and start looking up. Binoculars, a small telescope, a big telescope, whatever it is, get out there on a clear night and start looking up. If you're an early bird and want to get up in the morning right now, Jupiter, Saturn, Mars, and Venus are all up in the morning. Great things to look at, and you just got to get out there and start doing it. So that wraps up my presentation. What time is it? It's
434.
340, 434. So we're moving along okay. So, Paul, got anything you can read off of the
Not sure
restring?
how good it sounds because your microphone keeps picking me up no matter how quiet I am. Beatrice Hines, I'm from Belgium. And what country are you
Beatrice
from?
is from Belgium. That's correct.
Jim's Astro says you better bring a red light flashlight.
We didn't talk about red light flashlights. Very good. The people who have come to this were told, what to bring when I built this PowerPoint, but I'm going to add that to it. Red light flashlights. We mentioned it just a little bit. Lots of people have a flashlight, but they don't have red light flashlights. I found a very simple cure. Most big box retailers actually have a high-tech astronomy section. You probably didn't realize it, but if you look close enough, you're going to see that over in the party section, because this is where they put their high-tech astronomy gear, is in the party section, and find those bags of red balloons. And if you buy those bags of red balloons, buy a bag of 100 of them for like $1.99. Somebody shows up with a flashlight, you just stretch that red balloon over their flashlight, whether it's C cell or D cell or a little double A or whatever, and you have now created a high-tech astronomical red light simply out of a standard bright white light. And with that balloon over the end, they now have a high-tech red flashlight perfectly suited for a star party. And that's how
So,
you do it. I've actually, people who are driven to use their lights on their smartphones, I have stretched balloons over people's smartphones before, so they could use the flashlight on their smartphone to walk around, because they were driven to do it, scared to death of being out in the dark, had never been out in the dark before, and they just had to have light. So there's ways to deal with it.
so
And
James
red balloon.
Dugan says, what are the rules with EAA screens, electronic assisted
Okay.
astronomy, at
Yep.
star parties?
Okay. So generally, if it's an organized star party, you will have segregated areas. So you'll have the EAA folks who are doing astrophotography or assisted astronomy, and the differences are they've got their computers and they're sitting there processing images and not using their eyes. And then you've got the people who are using their telescopes hooked up with a camera, and they um, project the images their telescope and camera are on a screen. It's really good for bright stuff, Jupiter and Saturn, as well as the moon and some other things as well. So you got two versions. You got the people who are doing astrophotography, and then the people who are doing EAA, electronic assisted astronomy. And the star parties I've been at where they've been doing that, they will try to segregate those people into different groups. So the visual people are away from the bright screens. The other thing I've seen people do, a lot of them, is if they're doing astrophotography, they can either turn their screens red or put a red gel over it to try and preserve their night vision and not bother the people around them. Additionally, the two-room pop-up observatory tent that we have is a great tool for that as well, because one room is set up to be where the telescope's running, and the other is set up where you're sitting there doing the computer, doing astrophotography. So the fully black walls keep any light from going out the walls, and we have a tarp you can put over as long as it's not super hot, and the top of it, and that would contain all of the light you create.
So
Now, if you're doing straight,
Paul Bergart says most programs have a red screen option, but I was
uh-huh.
also curious if that was okay.
Absolutely. They either have a red screen option, or you can actually go in and not have the program, but turn the whole computer red. That's what I do on my iPhone. Is I turn the whole iPhone red. Whatever program I launch, it's red because I've set the screen to be red, and that's why I can use my smartphone at a star party and not ruin my night vision. I also turn the brightness way down so it's not bright as well. So for the people who are doing EAA, which means you're using your computer screen. I have a friend, Rick Marshall. He actually will project it up on a wall on a sheet or a screen and have Jupiter 2-3 feet across. And that just wows people. And we just put him away from everybody else. And then people can wander over there and check out what he's doing. And that's actually a good thing to use for eclipses. People will see that a lunar eclipse, I'm sorry. So when you're doing a lunar eclipse, EAA is fine because it's a full moon, right? You only have an eclipse during a full moon, and so you've already got the moon pumping out all sorts of light. So there's times when EAA won't affect anybody doing, true visual astronomy. But that's a great question. Thank you.
Mike Wiesner says that he will be at the Arizona Dark Sky Star Party in September.
Yep, and about 5 miles from his house. I'm going to consider him the host, if you will. It's going to be at Oracle State Park, September 1 through 25, I think. Make your reservations and get your tickets from our website and travel there. There's all sorts of options. Probably most people are going to fly into Tucson and then drive the distance over to Oracle. We had the first Arizona Dark Sky Star Party, which is hosted actually by David H. Levy of Comet Shoemaker Levy fame, renowned observer and popularizer of astronomy, discoverer of comets. You're going to get access to world-class speakers. I was sitting there at the first one, which was held at Kartchner Caverns State Park, south of Benson, Arizona. And I was sitting there, and I wish my dad could have been there, but he responded he couldn't travel. I'm sitting there, and I can't remember who was speaking, but David Levy, who I grew up reading about in Sky and Telescope and just hold in awe, was sitting right here. And sitting right here was Fred Espenak, who is Dr. Eclipse, renowned eclipse chaser. And sitting right behind me was Jack Newton, a pioneer in digital astrophotography and photography in general. And he was just fascinated by fascinated to hear him talk about what he did. And I was just blown away that I'm sitting there with three of my astronomy heroes, and I'm sitting between them. It was like, wow, what more could a kid think about? All right, so Mike Wiesner says, can't bring a 2-room observatory tent to the Arizona Dark Sky Star Party. I'm sure many would like to experience it. I plan on doing that, Mike. We're going to have probably a few there that we would sell there directly, but we're not going to bring a lot of stock because that just weighs down, slows down, and has us forced to work on, security. We're going to have security there, but, we just, over the years, Scott just has gotten to where he doesn't take a lot of product for sale. But we certainly, when people are there, we can certainly arrange to get an order shipped out. And if you buy something at the Star Party early enough, we might be able to have it delivered to Mike Wiesner's house and then deliver it to you. So Mike Overacker says, Norm. I think he's talking about to Norm Hughes. Norm. Thanks. That helpful to know when to best use appropriate optics, telescopes, or binoculars. CFOX 0011. I'll tell you, the best time to use them is when you want to go out. There's sometimes I go out and just use a pair of binoculars at night just to sort of gaze around and pick off a few things. There's other times that I'm going to be out longer, and I'll either put out a Dobsonian telescope, which are really easy because they have a ground board. You set them down there, lazy Susan, no polar lining. You just go. And there's other times I want to do some long viewing. I'll set up an equatorial mount. I'll get polar lined and go from there. So Beatrice, I just give a shout out to Mike
Everybody.
W, Paul, Nora, Michael, Billy, Jim, Harold, C. Fox, Anwa, and James. Glad to see the family is all together. It is cool how many people give us their times for these broadcasts and the community that's been built up around it. It is fascinating to see how everybody has these global connections. From James Dugan, G'day Kent, and Explore Scientific. Wiesner, you can ship orders to me. Glad to help out. Mike, that's probably what's going to happen. Early on, we'll take orders and have them, quick processed. And it's probably 3 days. So if we took orders on the first and second day, they'd be there before we left. We'll have to work that out. And Ken N says, I'm here lurking. We have all been large lurkers in our lives, and there's nothing wrong with being a lurker out there in the world and just be happy and go on down the road. So it's wonderful to see all these comments. Jim's Astro, you guys are awesome. Well, Jim, I'll tell you this.
No,
We're only awesome.
you're awesome, Jim.
That's where I was going.
You got to
We're
do
only
it
awesome
right.
because y'all are here making it awesome, right? Yeah, Scott's doing this and we're doing this to get it out there and really talking about education and trying to really have a good, rise all ships basically. But, without the audience there, this doesn't happen. And so, we're awesome only because you're there. James Dugan, cheers, Kent. Thank you very much. One of these days, I might make it to Australia and certainly will have to track you down and get you to take me out in your wonderful places. Now, I'm not going to have a on the wing tomorrow because Tyler and I are going to the Stars and Sauce Star Party, and he will not have focus on astrophotography on Friday either. Scott probably is going to jump on and do something, but James Dugan has sent me some really awesome video of kookaburras and one or two lorikeets. And lorikeets are sort of like a parakeet, beautiful, colorful bird. Kookaburras are big birds, and apparently he has either tamed them or they just don't care, and he hand feeds them off his back deck, the kookaburras. And the lorikeets are, when I say there's one or two, there's probably 30 to 50 in a feeding frenzy. It's great fun to watch. Beautiful birds. We will be talking about those next Thursday when I do On the Wing and watching some of that video. Ken in. Can't wait for you guys to highlight the 152 Mac Cas. Haven't done that. We have them in stock now. They came back in a few weeks ago. I'll work on that. Hadn't thought about it. It's a big old telescope. So, hello from Eastern Europe. Our Betelgeuse goes supernova soon. Matas Volkovas, Matas Volkovas. Part of me hopes it will, and part of me hopes it doesn't, because when it finally does go supernova from Earth, it'll be visible in daytime, and it will be way cool. But it will also dramatically change the appearance of one of my favorite constellations, and probably a favorite constellation of many, many people. So I'm mixed and torn, but boy, it sure would be cool to see something that close go off.
So the light would hit us,
Sorry?
right? The light would hit us.
Mm-hmm.
How long would it take for for if there was I don't think there even could be a shock wave, right?
Sure. I mean, we get gravitational waves have been detected by LIGO from merging neutron stars. I suspect that I'm shooting off the cuff. This is not my area of expertise or experience, but I think Betelgeuse is close enough that we probably would be able to detect the shock wave going through space. Jim's Astro Orion is definitely my favorite.
If it hit us, came by us, What would we experience, I wonder?
Nothing. It'd be a gravity wave, just like we don't experience the gravity waves. We're
Hmm.
far enough away; it's not going to blow us into smithereens or make the Earth shake or wobble. It's not going to be like that. I'm going to go out on a limb and say I'm 100% right on that. Uh, James Dugan says all those birds, the kookaburras and the lorikeets, are wild birds. I suspected they were. However,
And they jump all over you if you have food.
I think these birds would for sure.
Yeah.
Beautiful birds. The lorikeets are beautiful birds. Kookaburras are cool looking birds. They're not real colorful,
Very
but
noisy.
boy, kookaburras laugh in the old gum tree. You know the song.
Yeah.
Although there was no laughing, I could hear. He was feeding them meat, I believe,
What?
and then I can't remember what the
The
lorikeets he was feeding.
kookaburras? The kookaburras eat meat?
Lots of birds eat
Yeah, but a
meat.
kookaburra. I figured it'd just go around and like eat nuts
And,
and stuff.
and eat. I think
Bugs.
kookaburras probably eat whatever they dang well please because they're
Okay.
cool looking birds. All right, so this is cool. I can see the chat when the screen's big enough. When it's small, I couldn't read it.
Right.
So it will be cool to see a supernova in the sky, naked eye during the day. At night, I can't imagine what it's going to look like. The question from Mattis was, do we think it's going to go anytime soon? I don't know. I can't. Paul, Google real quick for me how far away Betelgeuse is. 16 light years sort
Okay,
of
you're
sticks in my head.
expecting me to be able to spell that correctly.
It'll figure it out. Heck, I can do it here. I can do it here. I've got the internet up on my computer. May not find that screen again.
642.5 light years.
642.5 light years away. I was only off by a factor of a bunch.
Yeah.
So 642 light years. Because, we're seeing the light that left Betelgeuse 642 years ago.
642
It very possibly has already gone
million.
supernova.
642 million years
Betelgeuse
ago.
is not 642 million light years away.
Wait, let's see. 642 light years. That's right.
642
I,
light years away.
I'm
So
usually home by now.
it very possibly has gone supernova, and we just have to wait for the light to get here because you got to remember when we look up in the sky, we're looking into the past because the light we see left, however far away that object is, the moon is a light second and a half away roughly. The sun is 8 minutes away. So if the sun goes out, just flips off like a light switch, which isn't going to happen, but if it could, it would take 8 minutes for us to know it. Jupiter averages 33 light minutes away. It's Voyager 2 is 39 or 40 light hours away. And that's just outside of the solar system now. It's 4 light years to the closest star. Let's see. And Lubo in China said, and Terry's may go boom soon too. James Dugan, cooked chicken. I feed them. They are an ambush hunter. Snakes, spiders, rats, that sort of thing.
All right.
Yep. And you say spiders, and I figure Australian spiders are going to be pretty big spiders, for a bird that big. Thomas Person, supernova is rare. Actually, recurrent nova is more common. Correct. The sun's going to go nova one of these days in 5 billion years. And as it goes through its life cycle and turns into a red giant or a supergiant, it's going to puff up and cool down, and Earth sadly will become part of the sun. And if I remember correctly, it's going to extend out to all the way out to the orbit of Mars.
Curious.
And Lubo in China, also Arcturus, has potential to go
Have a question.
supernova as well.
So
Yes.
you got the red giants, right? Have we ever found a green giant?
Not in the sky. Although your head's big enough and we could paint it green and be the green giant head.
That'd be
So
Tyler. Paint him green.
the sun goes nova every 12,068 years. It would be interesting. What I was going to say, it's interesting to look. We got people from China, people from the United States, obviously, people from Western Europe, people from Eastern Europe on here right now. I haven't seen Tariq. Tariq is on here all the
Where's
time.
Tariq?
Uh,
He wasn't
Tariq
here
is on.
earlier
He's
either.
Was he here earlier?
No.
Did you see Tariq earlier? So we haven't seen Tariq today. Tariq is from the UAE. So we truly have a global audience packed in here today.
We had a
I think
Canadian
it's
on
fantastic.
earlier.
Sir?
We had a Canadian on earlier.
Had a Canadian on earlier. I think it's just fantastic. We don't, on the afternoon ones, for some reason, we don't see a lot of people from South America. So we need to work on those numbers. I know that on the Global Star Parties, we have a couple of our dealers are on there very regularly. Cesar Brolo, and Rodrigo as well. So, I'd like to see us figure out a way to boost our South American audience. That way, we've got every continent covered, and except Antarctica. And I need to find an astronomer down there who has no time.
There may
Let's see,
actually
it's-
be one down there.
Oh, there very possibly could, but I don't know what their free time internet access is like down there. But it would be cool if we could find somebody in Antarctica,
Do they still
which
have dial-up?
looks like Mr. Dugan, James Dugan, is going into wintertime now because we're going into spring. They're going into winter time or fall and moving towards the winter. That would be cool to literally get somebody on the broadcast and we could have somebody on every continent. That would just be awesome. So
Isn't that
anyway,
supposed to be Global Star Party?
that indeed would make it a glow. And generally on the Global Star Party, we do have a very wide audience. We get the Far East, we get the Middle East. Tariq is on there sometimes, and then we do have people from South America on there as well. So it does become a global event. Somebody, Lubo in China. Actually, there are galaxies with supernova occurring quite often in them. I was going to say that, but got sidetracked. Lubo, you're exactly right. I took a photo of one after finding that one was going on in a galaxy I was imaging 3 weeks prior. So he
Send
was
it to
able
us.
to. Yeah, absolutely. Send it to us, Lubo. I would love to show that on a future show. You can send that to, and you don't have to use, we don't care what gear you, this is,
Yeah, it
but
doesn't matter.
you don't have to watch this show and you be an Explore Scientific gear user. Well, that's irrelevant to what we're doing. Send it to Explore Alliance. Paul, can you put that in there?
Maybe.
Explore Alliance at explorescientific.com. I'd love to show your pictures. So he managed to image a galaxy and then come back and image it again. And I'm sure very clearly, some of them are sort of hard to see, but some of them are obvious. You can say, wow, look, that's brighter. That was a supernova.
Explore
So I have
Alliance.
got Explore Alliance at explorescientific.com. Lubo says, so I have got one photo 3 weeks before and during supernova exploding. Dude, that is awesome, Lubo. Please send me your pictures, and I will show them on First Light Chronicles next week. And tell us a little bit about yourself. There it is, Explore.
Did I spell it right?
That's what I'm looking at right now, Paul.
Yeah.
Explore Alliance at explorescientific.com. There you go. You got it right.
Mediocre typer.
There you go. Typist.
No, typer. Typer
So, anyway,
actually makes more sense in the context of that I can't type.
I'll go with that. So, all right. Anyway, rolling up on 5 o'clock here. Time to have some final thoughts. My final thoughts are, and if you have some, throw them in here real quick. my final thoughts are there's no time like tonight to go up or go out and look at the stars. If it's clear, go take a look at what's up there. Get up in the morning, go look at the planets. Let's see, Mike Wiesner. If you have a dark sky, check out M60 Supernova 2224 HRS is in NGC 4647, which is the same eyepiece field of view as M60. It's brightening now, approaching magnitude plus 12. Obviously, you can Google that supernova in M60 or supernova 2022 HRS. You can Google that, find out exactly where it is, go out and see it. And, it's impressive, like Lubo did photographically, to get a picture and then come back and look at the other and go, wow, look at the difference. If you just go out tonight and look at it, you're not going to understand what it is. You need to observe it as it gets brighter and brighter and then starts getting dimmer and dimmer and disappears. Okay, Thomas asked, what does M stand for? M stands for Messier. Charles Messier was the court astronomer to the French court royalty in the 1700s. And at that time, they believed comets foretold a change of rain or a change of something. And so the kings, being, wanting to hold on to their throne, would employ the court astronomer to look for comets. And when said court astronomer found a comet, he would notify the king, who was, his benefactor, and the king would surround himself with his most trusted and loyal advisors or soldiers. And once the threat of the comet heralding change passed, he would go on about his business. Well, Charles Messier, his wife and assistant, had telescopes. Telescopes hadn't been around that long, and glass technology had not progressed very much. And he kept seeing these things that he knew weren't comets because they didn't move. Comets move. And so he started writing down, he and his wife and assistant started writing down this list of things that looked like comets in his telescope but didn't move. Well, he didn't know what they were, but they were just sort of nebulae, I think is what he just called them. But the Messier list is 110 things that weren't comets that he found in his telescope. He was in France, so these are visible anywhere in the northern hemisphere, down to the southern horizon, all the way up to the North Pole, the North Celestial Pole. They're visible in all. There's an M object in every constellation. They're now very accessible through amateur telescopes, and now we know that they're open clusters and globular clusters and nebula and galaxies and all sorts of other cool things. But the problem is the threat you get to seeing them now. We have better telescopes. Light pollution is extinguishing the night sky. The beautiful things that I can see 20 years ago very easily, naked eye, the same exact location I cannot see now because of light pollution. So these faint things up in the sky, when the sky glow gets to be the point that it's brighter than the faint thing you're trying to see, you'll never see it again. It's gone. It's disappeared. It's still there, but you can't see it. Light pollution is light that shines up in the sky for what we're talking about. There's other forms, but we're going to talk about this. Light pollution is what's light going up in the sky. If half the light a light bulb produces goes up in the sky, that means half the electricity it's consuming is being wasted because there's no reason to shine light up in the sky. We need light down on the ground for safety. So think about the right amount of time in the right place at the right time for the right reason in the right color. So many people equate bright white light to being better. But the reality is that bright white light is very harsh. It's very glary. It is bad for your eyes because it has a lot of digital blue light, you hear it called. And so that causes all sorts of other problems. A nice yellow incandescent color is what you want, even in LEDs. 2800K measures the temperature, light, temperature, and color, and the same thing in lighting. James Dugan, you should get Dylan O'Donnell, a YouTuber, very smart guy who does great astrophotography for your global star party. He is in Australia and has a good observatory and streaming setup. Yes, he does. I've seen Dylan, and he is a very interesting person to watch. I'll suggest that to Scott. Nebula, is that also called nova? No, a nova is a star that has exploded. A nebula is can be all sorts of various things. Clouds of gas that are being lit up and glowing or reflecting. There are nebula out there that are remnants of supernovas. The Crab Nebula is one. So that is a remnant and we've been taking pictures of the Crab Nebula long enough that you can take pictures and stack them up at the same size, and you can actually see the Crab Nebula is growing and becoming larger and larger. There's a number of nebula out there like that. There's also this thing called a Messier marathon out there. Thomas Pearson, does color first occur? I missed that. When energy hits Earth's envelope. We'll talk about color here in a second. Not my field, but I can make stuff up a little bit. So,
if you need to do that,
Messier
I can help.
marathon. Back in the 50s and 60s, when post-World War II optics started really flooding the market and better telescopes, some people discovered Messier's list, and it became a great entry point into amateur astronomy because it was dark still. There was very little light pollution. They were easy to find, and it really taught you the night sky. So back in the 70s, I believe it was two guys thought, between the middle of March and the middle of April, if we get these 4 or 5 Messier objects right in the sunset, and we stay up all night and get 4 or 5 right at sunrise, we can see all 110 of those objects in one night. And they did it. They stayed up, and they managed to see all 110 objects in one night. Now, on any given night, there's at least 80 or 85 visible. But at a specific time from middle of March to middle of April, you can see all of them if you have a clear horizon to the west and a clear horizon to the east and no light pollution. You can see all 110 objects in one night. It's a Messier marathon. Messier is spelled Messier. Look up Charles Messier or Messier objects, and you'll get a good education on them. So the most I've ever bagged in one night is like 65 or 70. Was moving along pretty good on a Messier marathon, and then the sky came in. The clouds came in. So talking about color, I'm not sure what the question is exactly. It's if you're talking about color, you're talking about the magnetic belts. If you're talking about color in the northern lights, the borealis, northern lights and southern lights, that's caused when radiation cascades down the magnetic lines and the strikes oxygen, hydrogen, and helium, if I remember correctly, and each one of those glows green, red, and blue, causing the aurora to fire off. It excites those molecules and they give off those colors. That's where the aurora come from. It's not the light that's doing it, it's the energy that's doing it. So, Paul, where are we at? 510?
Yeah.
All right, so we've got
506 or 7 or something like that.
506 or 7. Going along. Love the discussions. Love the questions. I hope most of my answers have been close to accurate. Some of them I know are accurate. Some of them, I'm reaching into my dark recesses of my mind to remember things I've read and are not fluent in. So I hope I have answered correctly. Paul's giggling at me over there. So anyway, I truly appreciate your time. Being live with customers is spectacular. Tyler and I will be doing live broadcasts Thursday, Friday, and Saturday. We may come on at night a little bit and listen to some music, and all depends on what the sky gives us. 60% chance last time I looked Thursday, 50% chance of storms Friday, and 50% on Saturday, and then beautiful on Sunday. I'm just hoping it doesn't turn into a mud pit music festival. If it does, hey, we'll still get on and broadcast live, bring you some of the music, and hopefully we're able to talk astronomy with a couple thousand people and get them to look up and realize the beauty of the sky out there. You do the same. Go find somebody, share your passion for the stars, and I wish you dark skies. Keep looking up, as in our friend Jack Horkheimer always said. So long, everybody. Bye-bye.